In this video presentation, we are going to solve a problem in electromagnetic theory. So here we are going to take the topic for solving the problem is basics of electrostatics. In that, we have already discussed in the previous video. There are two important parameters were taken as a reference parameters in electromagnetic theory. One is electric field intensity, the second one is electric flux density. So in this presentation, we are going to solve electric field intensity at any point due to charge. Now we are going to see the problem in electric field intensity. Determine the electric field intensity at a point P of minus 0.20 minus 2.3 due to the point charge of 5 nanocoulomb at Q of 0.2, 0.1, minus 2.5 in the air. All dimensions are in meter. So here what the data are given. Here the point that can be located at the Cartesian coordinates are minus 0.2, 0, minus 2.3, and we are going to find out the electric field intensity at this point due to the point charge of 5 nanocoulomb at Q is of 0.2, 0.1, minus 2.5. The medium which is given in this problem is air. Here the dimensions which are given in this problem is in meter. First step is to find the distance vector between the point and the point charge Q. So we know that the point P whose points will be minus 0.2, 0 and minus 2.3. So here the vector form it has been written as in Cartesian coordinates minus 0.2 AX plus 0 AY, because the point along y-axis is 0, minus 2.3 AZ. So here AX, AY and AZ are the unit vectors in Cartesian coordinates. Here the point which is located. The next one is point charge Q, whose points will be termed as 0.2 AX plus 0.1 AY minus 2.5 AZ. Now we are going to find out the distance between the point and the point charge Q. So whose formula is Rp minus Rq. Now we know that formula is x2 minus x1 into AX plus y2 minus y1 into AY plus Z2 minus Z1 into AY. So how will you calculate this R vector? Here we are taking the point is minus 0.2, 0, minus 2.3 and the charge is Q, that is 0.2, 0.1, minus 2.5. Here which can be taken as a x2, y2, z2 and which one be taken as a is x1, y1, z1. So here what we have assumed, the point at which the electric field intensity is going to be found out always taken as x2, y2 and z2. The charge, the coordinates of the charge will be taken as x1, y1, z1. So easily minus RQ can be written as minus 0.2 minus 0.2 into AX plus 0 minus 0.1 into AY plus minus 2.3 minus of minus we can get plus here 2.5 into AZ. So the resultant distance vector can be written as minus RP minus RQ is equal to minus 0.4 AX plus here minus 0.1 AY plus 0.2 into AZ. Now we are going to find out modulus of R vector. This can be written as R vector. So this can be taken as 0.4 square plus 0.1 square plus 0.2 square. So here the resultant vector of modulus of this resultant vector can be taken as 0.458. Step 2, we are going to find out the unit vector. The formula for unit vector is AR cap or AR vector. This is the notation of this unit vector, whose formula is R vector divided by modulus of R vector. R vector, we know that the R vector is minus 0.4 AXA. That can be found out from the previous step. So here this can be taken as minus 0.4 AX minus 0.1 AY plus 0.2 AZ. And this is the R vector, where modulus of R vector we have already found out in the step 1, whose value is 0.458. And this is the formula for your AR, that is unit vector. Step 3, this is the final step. In this step, we are going to find out the value for electric field intensity in the vector form. So when you are not putting this unit vector, your electric field intensity is given as a magnitude only. But if you are having the formula, E is equal to Q by 4 pi epsilon naught R squared, when it is multiplied by the unit vector, then the electric field intensity is expressed in terms of vector form. So now we are taking the formula for electric field intensity E is equal to Q divided by 4 pi epsilon naught R squared into AR. So directly we can substitute all the parameter here. So from the given data, we know that the charge whose value is 5 nanocoulomb. So nanocoulomb, it has been expressed in the standard unit, that is 5 into 10 power minus 9 divided by 4 into pi. Here we are going to take the another values epsilon r, but for air epsilon r is equal to 1. So only we are going to substitute this epsilon naught whose value is, this is called absolute permittivity, whose value will be 8.854 into 10 power minus 12 and r square. Now we are going to take the r square value. We have already found out the modulus of this r vector value, whose value is 0.458. You can square this one and into this AR vector. Now we are substituting this AR vector, 5 into 10 power minus 9 divided by 4 pi 8.854 into 10 power minus 12 into 0.458 square into AR. So now we are going to substitute this AR from the previous step, whose value is minus 0.4 AX minus 0.1 AY plus 0.2 AZ divided by 0.458. This is the value for your unit vector. Now multiplying all those values, we can get the answer for your electric field intensity in the vector form is minus 186.82 AX minus 46.65 AY plus 93.52 AZ. The unit of electric field intensity is volts per meter, and this is the introduction part. In this summary session, we have discussed to solve the problem in electric field intensity. As we have known, the electric field intensity is a basic parameter in electromagnetic theory. And this field intensity can be solved by using the direct formula. And we have all known the definition of electric field intensity, and it is defined as the force per unit charge. So we have known the formula for electric field intensity is E is equal to Q divided by 4 pi epsilon R square. When you are going to get the electric field intensity in a vector form, this formula can be multiplied with unit vector AR. Thank you.